Britain's rail network transports 3 million passengers and 400,000 tonnes of freight a day, with hundreds of trains using it at any one time. All this traffic presents us with a safety challenge. Trains are guided by rails, so it's impossible for them to swerve or pull over. Trains are heavy, can't stop quickly, and frequently operate at speeds which do not enable them to halt within sighting distance of the driver. Under these circumstances, one might assume that trains are prone to collision. In fact, rail is the safest mode of transport in Britain. And that's because trains are carefully controlled. And it's our responsibility at Network Rail to control them. Signalling is a control process Network Rail uses to operate trains safely over the correct route and to the proper timetable. The two key features of this process are line-side signals and the block system. Trains can't collide if they're not permitted to occupy the same section of track at the same time. So the network is divided into sections known as blocks. Normally, only one train is permitted in each block at any one time. The British Rail network uses line-side signals to advise a driver of the status of the section of track ahead. Most line-side signals are in colour light form, but a significant number of semaphore signals remain on secondary lines. The semaphore consists of a mechanical arm that raises to signify go, or lowers into the horizontal to signify stop. The most modern signals have 4 colour aspects. A green light indicates clear. A double yellow indicates that the next signal will be a caution. A yellow signal indicates caution and that the next signal will be red. And a red means stop, otherwise known as danger. It's prohibited to pass a signal at danger. The British rail network was originally controlled by thousands of manned signal boxes, located at regular intervals along the lines.
My name's Stuart Sentence. I'm the signaller at Utoxeter Signal Box. This is the most traditional form of system on the railway as it is at the moment. And a lot of this, as you see, it goes back to how the original railway started. As far as we're concerned, the universe begins at Caberswell, over to the right, and Sudbury there, and we're in the middle. This set of blocks tells me where the train is between myself and Caberswell, and this set of blocks tell me where the train is between Sudbury and myself. These levers here will operate the points for the crossings into the loops and the sidings. They'll also work the semaphore signals.
To prevent a collision caused by human error, a safety system called interlocking protects the railway network. Interlocking is a series of mechanical devices that prevents a signaller operating appliances in an unsafe sequence.
What you have here is what looks like a simple lever system. Is actually, if you looked underneath the box, is quite a complicated interlocking system. The interlocking system prevents me giving a green signal to approaching train unless I set that route and that interlocking system safely first. It sounds simple, and it basically works simple, but actually what it does is very good.
Lever frame signal boxes, while effective, aren't efficient. They only cover a short section of line, and manning them with skilled operators is expensive.
Now I can pull the signal off. Number 2. Some of these you'll see me pulling quite hard. That's because there's a lot of cable on these. Some people can't actually pull up at all. Well, a lot of it's fairly hands-on. You see the trains, you've got control over the trains and the job itself. It's a good job, better jobs I've ever had, without a doubt.
The next big leap in rail signalling control came with the electronic age and the advent of power signal control boxes like this one in Derby.
There's
This location opened in 1969, and when it did open, it represented a massive step forward to the railways in the way that trains are signalled. Well, these lines represent mainly the Derby to Birmingham main lines. This signal box actually took over 84 mechanical signal boxes, making it a far more efficient way of carrying out signalling.
Routes are set by pressing buttons on a large control panel. Each section between buttons represents a stretch of line formerly controlled by a lever frame signal box.
It's very easy to work around. The signalling system is very user friendly and very easy to see the layout of the trains and where they're coming from and going to. The presence of a train is indicated by these red lights on the panel. They're activated by the completion of an electrical circuit for when the train's wheels pass over the track circuit. The operation of the signalling equipment is carried out by pulling and pushing the actual buttons that are set in the panel. To set a route, you press the entrance button, you press the exit button, and the signalling system between detects all equipment that's located between the two signals. Once that's in the correct position, the signal will clear for the train to proceed. To take the route out, we simply pull the exit button and the route will drop out.
Power signal boxes are regulated by a relay room, a little like a giant mechanical computer.
This is the interlocking room underneath the operating floor of the power signal box. And in here are all the banks of relays. And these relays relay all of the information from the touches of the buttons upstairs from the signaller outside to the points and the track circuits and the level crossings.
Relays are interlocking electromechanical switches. When a signaller sets a route in the upstairs control room, you can hear the switches clicking, working out how to set the signals and switches and crossings, and whether the set route is safe.
These cabinets are where the equipment in Derby PSB reached the modern era. These allow the transmission of the train head code, the 4-digit running number that we saw on the panels upstairs, to be transmitted to adjacent signal boxes to give them advance notification of that train coming, so that train can be routed further down the line.
Powered signal boxes are effective and safe, but at Network Rail we are now introducing an even more efficient form of signalling control.
Compared to the oldest lever box signal boxes, this is a world apart. It's like an air traffic control centre, basically, but controlling trains instead of aeroplanes. My name's Jason Jones, I'm a signaller and I work at Ashford IECC in Kent. The IECC stands for Integrated Electronic Control Centre. All the signalling in this signalling centre is controlled by computers. A timetable is downloaded every day and any alterations, etc. are all programmed into the computer. When everything's running on time and all the trains are in their correct place and there's nothing else going on, the computers are all running the job and I am literally just sitting here monitoring. Hello driver, here's signal area 83 Ashford, over. At any time there could be an emergency of any description, and that's when I will then step in and take over from the computer. I will turn the computer off and then run the trains manually using the keyboard or the trackable system that we've got. On this screen here I can see the exact layout of the stations and the tracks. I can see where the trains are, where the red line is. Each red line indicates the location of the train. I can see where the trains are heading for, what route they're taking, by the white line. That's what the computer has set up for that train to use. We can also see the signals, what the driver sees out on the track. The red dots indicate a signal that's red. We've got a single yellow. We've also got a double yellow. And obviously we've got the green signals, which means then he can proceed at line speed. The computers that Network Rail uses in this type of location are specifically designed for this type of system. They use various safety protocols and various fail-safes. You get 3 computers working in tandem with one another, and before any decisions are made, 2 of the computers have to agree with one another. Ashford covers a huge area, right from the Kent coast at Folkestone, right the way into central London. That is the equivalent, of hundreds of the old style lever frame signal boxes. We don't just deal with standard trains here, as well as the commuter trains that we run. We also run the high-speed trains into St Pancras and the Eurostar trains that come from Paris and Brussels. The high-speed trains are run using a totally different way of signalling trains to the old style and conventional signals. The high-speed line is signalled using cab signalling, where the driver gets a display in the cab and that tells him when to stop his train, start his train and what speed he must run at. The trains travel up to 186 miles an hour and that's just too fast for the driver to be able to see signals out on the track. All the systems, whether you're in a lever box or you're in this type of modern technology, it's all designed to fail safe, and that is any failures, the signals go back to red. This job carries a lot of responsibility. You are responsible for people's lives on the trains, the public, the drivers, the track workers. You do have a fair bit of responsibility. No matter how much technology changes, the one thing that remains the same is the safety and the security of the trains out on the track.